Thank you for joining another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and in this chapter, we are going to review the basic operations to polynomials. We'll discuss the different components of a polynomial. We'll review how to add, subtract, multiply, and divide polynomials as well. Should you have any follow-up questions, feel free to leave them in the comments section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. So let's kick things off by reviewing what a polynomial is. A polynomial is an expression with multiple terms. A term can be a constant, a variable, or a multivariable monomial. So this polynomial in front of us has three different terms that are examples of each of these. Negative 2x cubed yz is one term with multiple variables. They're all being multiplied times each other, so it's all considered one term. This would be a multivariable monomial. 7x is an example of another term. We have a coefficient 7 being multiplied times a variable x. And 4, which is a constant, and together all three of these terms constitute a polynomial, multiple terms. Throughout this video, we'll be discussing how to go about adding, subtracting, multiplying, and dividing polynomials. But first, let's continue discussing what constitutes a term that's allowed to be in a polynomial. In the denominators, for example, a term can be divided by a constant but not by a variable. So we cannot have variables in our denominators. The exponents of the variables can be equal to 0 or a positive integer, but not a negative value. So 4xy squared divided by 3 is a term that would be allowed in a polynomial. In the denominator, we have just the constant 3. There's no variable in the denominator. But if we change the denominator to a variable z, this term would not be allowed in a polynomial. And if you have both a variable and a constant in the denominator, this term would not be allowed either because the variable is in the denominator. Even if this is written with z in the numerator, if it had a negative exponent, that would not be allowed as well. Z in the denominator is equivalent to z to the negative 1 in the numerator, so keep a lookout for that as well. None of the exponents for variables are allowed to have a negative value. Remember that. A radical sign is the result of a fractional exponent. A constant in a polynomial can have a fractional exponent, but a variable cannot. So the square root of 5 and the square root of 9 are allowed to be a part of the terms in a polynomial. But the square root of x, or the square root of x times y squared times z, none of these would be allowed because these variables would then have exponents that are fractions. Variables cannot be in the denominator, and variables cannot have fractional exponents. If so, then that term cannot be a part of a polynomial. So you will not see any expressions with these types of terms throughout this chapter. Now there are some special polynomials that you will see frequently. A polynomial is also known as a monomial if it has one term. So for example, the constant 3 is a monomial. 4x, a coefficient of 4 times the variable x, is considered a monomial. They're being multiplied times each other. So this product is considered a singular term. And negative 7xy squared z cubed, they're also being multiplied times each other. So this is all considered one term, and a singular term, again, is considered a monomial. A polynomial is also known as a binomial if it has two terms. So a couple examples of binomials. One example would be 6xy plus 11. So we have one term, 6xy, and another term, the constant 11. Together, this expression would be considered a binomial, a polynomial with two terms. The coefficient can also be a fraction. So negative 13x over 2 is considered a singular term, minus yz. These are being multiplied, so it's also considered a singular term. So two terms would give us another example of a binomial. And a polynomial is known as a trinomial if it has three terms. So x squared plus 5x minus 8 would be one example of a trinomial. And 5x squared plus 6y minus 2 would be an example of another trinomial. So we'll be discussing how to go about using the basic operations with all these types of polynomials throughout the remainder of this chapter. Let's now discuss the degree of a polynomial. The degree of a polynomial refers to the order of the expression, not an angle. The degree or order of a polynomial with only one variable is equal to the largest exponent. So for example, if we had this polynomial here, 9x cubed minus 4x squared plus x minus 2, we're going to look at the individual terms in the polynomial, and the degree of this entire polynomial will be equal to the largest exponent. So we'll start with our constant, negative 2. Constants all have a degree equal to 0. We then look at the next term, x. This x has an exponent of 1, so the degree of this term is equal to 1. Then we have negative 4x squared. The constant has a degree equal to 0. The variable x has an exponent equal to 2, so this term has a degree equal to 2. And 9x cubed, 9 has a degree of 0, x has a degree of 3, so this term has a degree of 3, and the degree of the entire polynomial is equal to the degree of the largest exponent. So the degree of 9x cubed minus 4x squared plus x minus 2 is equal to 3. And you represent the degree of a polynomial by putting the polynomial inside a pair of parentheses and preceding that expression with deg for degree. So the degree of this polynomial is equal to 3. If you were given the polynomial x to the 7th plus 3x to the 4th minus 11x, the degree of this expression would be equal to 7, since the largest exponent in the expression is 7. This variable has an exponent of 1, this variable has an exponent of 4, and this variable has an exponent of 7, and the degree or order of a polynomial with only one variable is equal to the largest exponent. So we only have x in this polynomial, and the largest exponent is equal to 7. So the degree of the polynomial is equal to 7. Another example, if we had x to the 8th minus 2x cubed plus 9x squared, this term, 9x squared, has a degree equal to 2. This term, negative 2x cubed, has a degree equal to 3. And this term, x to the 8th, has a degree equal to 8. So the largest exponent in the polynomial is 8. So the degree of the polynomial is equal to 8. So that's how you find the degree of a polynomial that only has one variable. Some special polynomials. A constant, again, which is a number, has a degree equal to 0. A polynomial is considered linear if the largest exponent in the polynomial is equal to 1, such as x minus 1. The exponent of x here is 1, so the degree of that polynomial is 1. You also have quadratics that have a degree equal to 2 because the largest exponent in the expression is equal to 2. So x squared minus 9, for example, is considered a quadratic expression, and quadratics have a degree equal to 2. And you also see variables that have a degree equal to 3 pretty frequently throughout algebra. These expressions are considered cubic, such as x cubed plus 1. So these are just a few of the different types of polynomials that you'll come across pretty frequently throughout algebras 1 and 2. Now let's discuss how we find the degree of a polynomial that has more than one variable. If a polynomial has more than one variable, then the degree will be equal to the largest degree in the polynomial. So let's say we had the polynomial negative 3x squared y plus 2x cubed yz minus z to the fourth plus 6. The degree of this expression is equal to 5. But how do we find the degree since we have 1, 2, 3 variables throughout this polynomial? Well, the degree of a single term with multiple variables is equal to the sum of the exponents in the term. So let's look at this step by step. Starting furthest to the right, we have a constant 6. Constants have a degree equal to 0. So we'll look at the next term, z to the fourth. The degree is equal to 4 since the exponent is 4 and we only have one variable. And then we have 2 times x to the third times yz. This term has a degree equal to 5. If we add up the exponents for the 3 variables, z has an exponent of 1, y has an exponent of 1. Remember, anything to a power of 1 is just itself. So when you don't see the exponent is 1. So we get 1 plus 3 plus 0, and that would be equal to 5. And then lastly, we have negative 3x squared times y. If we add up the exponents, we get 1 plus 2 plus 0, which would be equal to 3. So when we find the sum of the exponents for each term, that shows us that the degree of this polynomial is equal to 5. We had a degree of 0, a degree of 4, a degree of 5, and a degree of 3. So the largest degree in this polynomial is 5. So the degree of the entire polynomial is equal to 5. So when you want to find the degree of a polynomial, you find the sum of the exponents for each term. Let's now have you try a few practice questions. Question number 1. Find the degree of 4x to the fifth minus x cubed plus 6x. Question number 2. Find the degree of 6x to the third minus 5x to the second y to the second plus 7xy. In question number 3, find the degree of negative 5xy squared plus 4y to the second z to the second minus 3x to the third z squared. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we had the polynomial 4x to the fifth minus x to the third plus 6x. To find the degree, we want to find the sum of the exponents for each term. So this first term, we have 6x. The exponent for the x is 1. So the degree of this term is equal to 1. Then we have x to the third. This variable has an exponent of 3. So this term has a degree equal to 3. And then we have 4x to the fifth. X to the fifth has a degree equal to 5. So since this is the largest degree of the polynomial, then the degree of 4x to the fifth minus x to the third plus 6x is equal to 5. Question number 2. We were given the polynomial 6x to the third minus 5x to the second, y to the second, plus 7xy. So let's find the degree of each term. We have 7xy. So the sum of the exponents would be equal to 1 plus 1, which is 2. So the degree of 7xy is equal to 2. Then we have 5x squared y squared. The sum of the exponents for the variables is 2 plus 2, which is equal to 4. So the degree of this term is equal to 4. And then the third term, we have 6x to the third. The variable has an exponent equal to 3. So the degree of this term is equal to 3. So we have a degree of 3, a degree of 4, and a degree of 2. So the degree of the entire polynomial is equal to 4. In question number 3, we were given negative 5xy squared plus 4y cubed z minus 3x cubed z squared. The degree of 3x cubed z squared is equal to 2 plus 3, which is equal to 5. The degree of 4y cubed z is equal to 1 plus 3, which is equal to 4. And the degree of negative 5xy squared is equal to 2 plus 1, which is equal to 3. So we have a degree of 3, a degree of 4, and a degree of 5. So the degree of the entire polynomial is equal to 5. So that is how we go about finding the degree of a polynomial. Let's now discuss the basic operations, and we'll kick things off by reviewing how to add polynomials together. To add terms, each term must have the same variables with the same exponents, and you combine the like terms by adding the coefficients. So for example, let's say we had 3xy plus 4xy squared. That would be equal to 3xy plus 4xy squared, since we cannot combine these two terms. The reason being, the first y has an exponent equal to 1, and the second y has an exponent equal to 2. So since these exponents are not the same, we cannot combine these two terms. But if this exponent instead of 1 were equal to 2, and we had 3xy squared plus 4xy squared, since we have the same variables with the same exponents, xy squared, xy squared, then we can add the coefficients 3 and 4 to give us 7xy squared. Okay, so to add terms in a polynomial, each term must have the same exact variables with the same exponents. Since these are being multiplied, the variables do not need to be in the same order. They just all need to be present. So y squared times x is equal to x y squared. So the order doesn't matter. They just need to have the same variables with the same exponents. Let's take a look at another example. Let's say you're asked to find the sum of negative 5x squared y plus 3x squared y squared minus 2xy cubed plus 7x squared y minus 8xy cubed plus 9x squared y squared. If you wanted to add these two polynomials, then the first step is to combine the like terms. The like terms are the terms with the same exponents with the same variables. So the first term, we had negative 5x squared y. So we want to add that to 7x squared y. We add their coefficients, so we get negative 5 plus 7, which gives us 2x squared y. Then you go to the second term of the first polynomial, which was 3x squared y squared, and you combine that to any term in the second polynomial that has the same variables with the same exponents. And we have one term, 9x squared y squared, that has the same exponents with the same variables. So when we add their coefficients, we get 3 plus 9, which gives us 12x squared y squared. And then you go to the next term in the first polynomial. So you go to the first term, combine it with any like terms. Go to the second term, combine it with any like terms. You go to the last term, negative 2xy cubed, and you combine it with any like terms, which in this case would be negative 8xy cubed. And when we add their coefficients, we get negative 2 minus 8, which is negative 10xy cubed. So after we add the two polynomials, we get 2x squared y plus 12x squared y squared minus 10xy cubed. The next step, you want to convert the polynomial to standard form. Standard form means you have the terms with the largest degrees furthest to the left. So if we look at our answer, this term has a degree of 4. 3 plus 1 would give us 4. This term has a degree equal to 4. 2 plus 2 would give us 4. And this term has a degree equal to 3. 1 plus 2 gives us 3. So this term should be listed furthest to the right since it has the smallest degree. And these two terms should come before it since they both have a degree equal to 4. So the final answer in standard form is 12x squared y squared minus 10xy cubed plus 2x squared times y. And that is how you go about adding polynomials. Let's now have you try a few practice questions. Question number 1. Find the sum of 11x squared y minus 4xy plus negative 8x squared y plus 9xy plus 2xy squared. Question number 2. Find the sum of negative 7x plus 3yz squared minus 6x cubed z plus 10x cubed z minus 6x plus 8yz squared. In question number 3, find the sum of 10x squared yz squared plus 7y cubed z minus 3y squared z plus 2y cubed z plus 6y squared z minus 5x squared yz squared. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, combine the like terms. So we go to the first term of our first polynomial, 11x squared y. The variables and exponents are x squared y. So we want to combine that with any other term with the same variables and exponents. And that would be negative 8x squared y. So we add their coefficients. 11 minus 8 is equal to 3. X squared y. You then go to the next term of the first polynomial, negative 4xy, and combine that to any other like terms in the remaining expressions. We then want to combine it with 9xy, so we add their coefficients. Negative 4 plus 9 gives us positive 5xy. And then we have 2xy squared, and no other term has these variables with exponents, so we just bring that down as is. So we get 3x squared y plus 5xy plus 2xy squared, and then we want to convert the polynomial to standard form. So this term has a degree equal to 3. 2 plus 1 equals 3. This term has a degree equal to 2. 1 plus 1. And this term has its degree equal to 3. 2 plus 1. So to convert the polynomial to standard form, 3x squared y plus 2xy squared have to go before 5xy, since both of these terms have a degree of 3 and 5xy has a degree of 2. So the final answer in standard form is 3x squared y plus 2xy squared plus 5xy. Question number 2. we wanted to add negative 7x plus 3y z squared minus 6x cubed z plus 10x cubed z minus 6x plus 8y z squared. We'll go to the first term of the first polynomial and combine that to any other like terms, which would be negative 6x. So when we combine the coefficients, we have negative 7 minus 6, which gives us negative 13x. We then go to the next term in the first polynomial, 3yz squared, and we combine that to any other like terms, and we have 8yz squared. So when we add the coefficients, we have 8 plus 3, which gives us 11yz squared. Then we go to the next term of the first polynomial, negative 6x cubed z, and we combine that with 10x cubed z, giving us negative 6 plus 10, which is positive 4x cubed z. So we have negative 13x, which has a degree of 1, plus 11yz squared, which has a degree of 3, plus 4x cubed z, which has a degree of 4. So to convert the polynomial to standard form, this term should be first, this term should be second, and this term should be third, giving us a sum of 4x cubed z plus 11yz squared minus 13x. In question number 3, we were asked to find the sum of 10x squared yz squared plus 7y cubed z minus 3y squared z. And we were adding that to 2y cubed z plus 6y squared z minus 5x squared yz squared. So we'll go to the first term of the first polynomial, 10x squared yz squared, and combine that with the like term, negative 5x squared yz squared, giving us 10 minus 5, which is 5x squared yz squared. We then go to the next term of our first polynomial, 7y cubed z, and we combine that with 2y cubed z to give us 9y cubed z. And then the third term in the first polynomial, negative 3y squared z, we combine with positive 6y squared z. Negative 3 plus 6 gives us positive 3y squared z. This term has a degree equal to 5. 2 plus 1 plus 2 is equal to 5. This term has a degree equal to 4. 3 plus 1. And this term has a degree equal to 3. 2 plus 1. So since the degrees are 5, 4, and 3, this answer is in standard form. So the final answer is 5x squared yz squared plus 9y cubed z plus 3y squared z. So that is how we go about adding polynomials. Let's now discuss how we go about subtracting polynomials. To subtract terms, each term must have the same variables with the same exponents, and you combine the like terms by subtracting the coefficients. So for example, if we had 6xy squared minus 3xy, we would not be able to simplify that any further because the exponent of y here is 1 and the exponent of y here is 2, so we cannot combine these two terms. But if the exponent of both y's were 2, then we would have the same variables with the same exponents. So then we can combine by subtracting the coefficients. 6 minus 3 to give us 3xy squared. And remember, since we're multiplying these terms, the variables do not need to be in the same order. So we could get 3y squared x, and that's a like term to 6xy squared. You'd have the same variables with the same exponents, and it's multiplication, so the order in which you are multiplying them does not matter. So keep that in mind. Let's take a look at another example. Let's say you're asked to find the difference of 6xz plus 8z plus 5xyz cubed minus 7xyz cubed plus 4z minus 3xz. Since this polynomial is subtracting this entire polynomial, then you can start by distributing this -1 to each of the 3 terms inside of this second polynomial here. So step 1, distribute the -1 to the second polynomial. The positive 7 becomes -7, positive 4 becomes -4, and -3 becomes positive 3. And now that we've done that, we can combine the like terms for all 6 terms. So we'll start with the first term in the first polynomial, 6xz. We can combine that with 3xz, giving us 3 plus 6, which is 9xz. We then go to the second term of the first polynomial, 8z, and we can combine that with -4z. 8 minus 4 gives us 4z. And then the last term of the first polynomial, 5xyz cubed, can be combined with -7xyz cubed. 5 minus 7 would give us -2xyz cubed. And now that we've combined the like terms, we want to convert the polynomial to standard form. This first term has a degree of 2. 1 plus 1 would give us 2. The second term has a degree of 1. Z has an exponent of 1. And this third term has a degree of 5. 1 plus 1 plus 3. So this term should be first, 9xz should be second, and 4z should be third. So the answer in standard form is equal to -2xyz cubed plus 9xz plus 4z. So that is how we go about subtracting polynomials. Let's have you try a few practice questions. Question number 1. Find the difference of 5x cubed plus 7 minus 2x minus -4 plus 3x cubed minus 2x. Question number 2. Find the difference of 4xy minus 5x minus 6x squared y minus 2x squared y minus 3xy plus 4x. In question number 3, find the difference of 8y squared minus 5xz cubed plus 2x cubed z squared minus -6x cubed z squared minus 2y squared minus 7xz cubed. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We were asked to find the difference of 5x cubed plus 7 minus 2x minus -4 plus 3x cubed minus 2x. Step 1, distribute the -1 to the second polynomial. -4 will become +4. +3 will become -3. And -2 will become +2. So once we've distributed our negative that represented subtraction, we can now combine the like terms. 5x cubed minus 3x cubed gives us 2x cubed. 7 plus 4 gives us 11. And -2x cancels out +2x. So the answer would be 2x cubed plus 11. Question number 2, we had 4xy minus 5x minus 6x squared y minus 2x squared y minus 3xy plus 4x. When we distribute the -1 to the second polynomial, +2 becomes -2, -3 becomes +3, and positive 4 becomes negative 4. And now the second step, we can combine the like terms. 4xy plus 3xy would give you 7xy. Negative 5x minus 4x gives you negative 9x. And negative 6x squared y minus 2x squared y would give you negative 8x squared y. And now we want to convert the polynomial to standard form. Negative 8x squared y has a degree equal to 3. 1 plus 2 equals 3. Negative 9x has a degree equal to 1, x to the 1. And 7xy has a degree equal to 2. So in standard form, negative 8x squared y goes first, 7xy goes second, and negative 9x goes third, giving us a final answer of negative 8x squared y plus 7xy minus 9x. In question number 3, we had 8y squared minus 5xz cubed plus x cubed z squared minus negative 6x cubed z squared minus 2y squared minus 7xz cubed. When we distribute the negative 1 to the second polynomial, negative 6 becomes positive 6, negative 2 becomes positive 2, and negative 7 becomes positive 7. And now, the second step, we can combine the like terms, giving us 8y squared plus 2y squared, which is 10y squared. Negative 5xz cubed plus 7xz cubed is equal to 2xz cubed. And 2x cubed z squared plus 6x cubed z squared is equal to 8x cubed z squared. And now we want to convert the polynomial to standard form. 8x cubed z squared has a degree equal to 5, 3 plus 2. 2xz cubed has a degree of 4, 3 plus 1. And 10y squared has a degree of 2, y squared. So in standard form, the final answer is 8x cubed z squared plus 2xz cubed plus 10y squared. And that is how we go about subtracting polynomials. Let's now discuss how we would go about multiplying polynomials. Unlike addition and subtraction, for multiplication, any terms can be multiplied by multiplying the coefficients and by adding the exponents of the like variables. So let's say we were multiplying the monomial 7x to the 4th y squared times the binomial negative 2x cubed y to the 6th plus 5y squared z. You multiply the first polynomial, 7x to the 4th y squared, times the first term in the second polynomial, giving us 7 times negative 2, which is negative 14. X to the 4th times x to the 3rd is equal to x to the 4 plus 3, which gives us x to the 7th. And y to the 2nd times y to the 6th equals y to the 2 plus 6, which is y to the 8th. And now you'll want to distribute the term on the outside to the second term on the inside, giving you 7 times 5, which is 35. X to the 4th. There are no x's in this term, so we still have x to the 4th. Y to the 2nd times y to the 2nd equals y to the 2 plus 2, which is 4. And in this term we have z. This one we don't, so we keep our z. So the product would be negative 14 x to the 7th, y to the 8th, plus 35 x to the 4th, y to the 4th z. So if you have a monomial times a polynomial, you multiply the monomial times each term in the polynomial. Similarly, when multiplying two polynomials, both of which have 2 or more terms, multiply each term in the first polynomial times each term in the second polynomial. So for example, if we had A plus B plus C times D plus E plus F, you're going to take each term in the first polynomial and multiply it times each term in the second polynomial. So we'll take our first term A and multiply it times all three terms in here, giving us A times D, which is AD, A times E, which is AE, and A times F, which is AF. So now that we've multiplied this term times all three of these terms, you then go to the next term in this polynomial and repeat the same process. So you're going to multiply it times all three terms again, giving us B times D, which is BD, B times E, which is BE, B times F, which is BF. So now we've multiplied this term times all three. So now we want to multiply the next term in our first polynomial, C, times all three terms, giving us C times D, which is CD, C times E, which is CE, and C times F, which is CF. So this would be our final answer. But again, regardless of how many terms are in each polynomial, you're going to multiply each term in the first polynomial times each term in the second polynomial. Let's have a look at another example. Let's say you're asked to find the product of 2x minus y times negative 4x plus 3y. You're going to go to the first term in the first polynomial and multiply it times each term in the second polynomial. And then you'll go to the second term in the first polynomial and multiply it times each term in the second polynomial. So step 1, multiply each term in the first polynomial times each term in the second polynomial, giving us 2x times negative 4x, which is negative 8x squared. Then we do 2x times 3y, which would give us 6xy. Then we go to the next term, negative y, and multiply it times negative 4x, which would be positive 4xy. And then we have negative y times positive 3y, which gives us negative 3y squared. So after we've multiplied each term in the first polynomial times each term in the second polynomial, we get negative 8x squared plus 6xy plus 4xy minus 3y squared. And the second step, combine the like terms. So we have 6xy plus 4xy, which would give us 10xy. And the first term has a degree of 2. The second term has a degree of 2. And the third term has a degree of 2. So the answer is in standard form. So the product of 2x minus y times negative 4x plus 3y is equal to negative 8x squared plus 10xy minus 3y squared. And that is how we go about multiplying polynomials. Let's now have you try a few practice questions. Question number 1. Find the product of 6x squared y times negative 2x to the fourth plus 5xy squared. Question number 2. Find the product of 8xy plus 2x times negative 3xy minus 5xz. And question number 3. Find the product of 4x plus z times x squared minus x plus 1. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We're asked to find the product of 6x squared y times negative 2x to the fourth plus 5xy squared. So step 1, multiply each term in the first polynomial times each term in the second polynomial. Our first polynomial is a monomial 6x squared y, so we'll distribute this term to both of these terms in here, giving us 6 times negative 2, which is negative 12. X to the second times x to the fourth is equal to x to the 4 plus 2, which is x to the sixth. And we have y times nothing, so we just have y. And then we multiply our monomial times 5xy squared. 6 times 5 is 30. X squared times x is x to the 2 plus 1, which is 3. And y times y squared is y to the 1 plus 2, which is y to the 3. Our final answer is negative 12 x to the 6th y plus 30 x cubed y cubed. And this is in standard form already, since this term has a degree of 6 and this term has a degree of 7. Question number 2. We're asked to find the product of 8xy plus 2x times negative 3xy minus 5xz. So step 1, multiply each term in the first polynomial times each term in the second polynomial, giving us 8xy times negative 3xy, which would be negative 24x squared y squared. Then we multiply this term times the second term, giving us 8 times negative 5, which is negative 40. X times x is x squared. Y times nothing is y. And z times nothing is z. And now we'll take 2x and multiply it times both terms, giving us 2x times negative 3xy, which is negative 6x squared y. And then we multiply 2x times negative 5xz, giving us negative 10x squared z. And since none of these are like terms, and it's already in standard form, degree of 3, degree of 3, degree of 4, and degree of 4, then the final answer is negative 24x squared y squared minus 40x squared yz minus 6x squared y minus 10x squared z. In question number 3, we're asked to find the product of 4x plus 7 times x squared minus x plus 1. So step 1, multiply each term in the first polynomial times each term in the second polynomial. So 4x times x squared is 4x cubed. 4x times negative x is negative 4x squared. And 4x times 1 is equal to 4x. And now we go to the next term in the first polynomial. It will multiply it times all 3 terms in the second polynomial, giving us 7 times x squared, which is 7x squared. 7 times negative x is negative 7x. And 7 times 1 is equal to 7. And now that we've multiplied all the terms, we can combine the like terms. So we have 4x cubed, negative 4x squared plus 7x squared gives us negative 4 plus 7, which is positive 3x squared. 4x minus 7x is negative 3x plus 7. So the product of 4x plus 7 times x squared minus x plus 1 is equal to 4x cubed plus 3x squared minus 3x plus 7. And this is in standard form. So that is how you go about multiplying polynomials. Let's now discuss how we go about dividing polynomials. First, a quick review of exponents and division. If a variable is being divided by the same variable, then the quotient can be found by subtracting the exponent in the denominator from the exponent in the numerator. So for example, the variable x can only be divided by x. When we do so, you take the exponent in the numerator and subtract the exponent in the denominator, giving you x to the 8 minus 3. And 8 minus 3 is equal to 5. If you had multiple variables, you only divide a variable by the same variable. So x to the 5th, y to the 8th, divided by x squared, y to the 4th, is equal to x to the 5 minus 2, which is equal to x to the 3rd. And y to the 8 divided by y to the 4th is equal to y to the 8 minus 4. And that would be equal to 4. So you divide coefficients by coefficients, and you divide variables by their like variables by subtracting the exponents in the denominator from the exponents in the numerator. Now, if you are dividing a polynomial by a monomial, then the quotient can be found by dividing each term in the numerator by the denominator. So for example, 8x cubed y plus 6xy plus y divided by 2xy would be equal to 4x squared plus 3 plus 1 over 2x. How do we do this? Well, let's take a look at this a little bit closer. Step 1, divide each term in the numerator by the term in the denominator. So 8 divided by 2 is equal to 4. X to the 3rd divided by x is equal to 3 minus 1, which is x squared. And then y divided by y is 1. So those cancel each other out. So when we divide the first term, we get 4x squared. Now the second term, 6 divided by 2 is equal to 3. X divided by x is 1, so that cancels out. And y divided by y is equal to 1, so that cancels out. So we get 3 as the second term in our answer. Here, since there's no coefficient shown, the coefficient would be 1. 1 times y is just y. So 1 divided by 2 is 1/2. There's no x in the numerator, but there's an x in the denominator, so that stays. And then we have y divided by y, which is equal to 1, so those cancel each other out. So the quotient would be equal to 4x squared plus 3 plus 1 over 2x. And although this term would not be allowed in a polynomial, this is the answer to this quotient, so it is allowed to be a part of our answer. So don't let this throw you off. Let's now have you try a few practice questions. Question number 1. Find the quotient of 12x squared plus 9x plus 1 over 3x. Question number 2. Find the quotient of negative 8x cubed y squared plus 16x squared y minus 2xy divided by 4xy squared. And question number 3, find the quotient of 20xyz cubed plus 14xy squared plus 6xyz divided by 2xz squared. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we had 12x squared plus 9x plus 1 divided by 3x. So step 1, divide each term in the numerator by the term in the denominator, giving us 12 divided by 3, which is 4. X squared divided by x gives us x. 2 minus 1 would be 1. Then we go to the next term. 9 divided by 3 is equal to 3. X divided by x is equal to 1, so that cancels out. And then we have 1 over 3x. So the quotient of 12x squared plus 9x plus 1 divided by 3x is equal to 4x plus 3 plus 1 over 3x. Question number 2. We're asked to find negative 8x cubed y squared plus 16x squared y minus 2xy divided by 4xy squared. Step 1, divide each term in the numerator by the term in the denominator. giving us negative 8 divided by 4, which is negative 2. X cubed divided by x is equal to x squared. 3 minus 1 is 2. Then we have y squared divided by y squared, which is equal to 1. So those cancel each other out. Then we go to the next term in the numerator. 16 divided by 4 is equal to 4. X squared divided by x is equal to x. Y divided by y squared would give us y to the negative 1. 1 minus 2 would be negative 1. Y to the negative 1 is equivalent to y to the positive 1 in the denominator. So we get 4x over y. And then we have negative 2xy divided by 4xy squared, giving us negative 2 divided by 4 is negative 1/2. X divided by x cancel each other out. And y to the 1 divided by y to the 2 is equal to y to the negative 1, which is equal to y to the positive 1 in the denominator. So the quotient is equal to negative 2x squared plus 4x over y minus 1 over 2y. In question number 3, 20xyz cubed plus 14xy squared plus 6xyz divided by 2xz squared. Step 1, divide each term in the numerator by the term in the denominator, giving us 20 divided by 2, which is 10. X divided by x is 1, so let's cancel each other out. There is no y in the denominator, so we keep our y. And z to the third divided by z to the second is equal to z. Then we have 14 divided by 2, which is 7. X divided by x is 1, so let's cancel each other out. And y squared is not being divided by another y, so we keep our y squared. And we don't have a z in the numerator, but we have a z squared in the denominator, so we keep z squared in the denominator. Then we have 6xyz divided by 2xz squared, giving us 6 divided by 2, which is 3. X divided by x is 1, so let's cancel each other out. We keep our y from the numerator since it's not being divided by another y. And z divided by z squared gives us z to the negative 1, which is equal to z to the positive 1 in the denominator. So the quotient is equal to 10yz plus 7y squared over z squared plus 3y over z. And that is how you go about dividing a polynomial by a monomial. Let's wrap up the chapter by discussing how we go about dividing a polynomial by another polynomial. And we'll be using long division specifically. If a polynomial is being divided by a polynomial, then the quotient can be found by removing the greatest common factor or by long division. So for example, 4x squared plus 13x plus 3 divided by x plus 3. This can be simplified by breaking up 4x squared plus 13x plus 3 into two factors, 4x plus 1 times x plus 3. And this factor in the numerator, x plus 3, cancels out x plus 3 in the denominator, leaving you with just 4x plus 1. So that is how you would find the quotient through factoring. We are going to save factoring for the second part to our polynomials chapters. So check out that video for all the different methods of factoring polynomials. But for this section, we are going to discuss long division. So I'm going to show you how to divide 4x squared plus 13x plus 3 by x plus 3 through long division instead, and we'll still get 4x plus 1. But before we do that, let's quickly discuss a few things. When dividing a polynomial with long division, organize the polynomial being divided, i.e. the dividend, in descending order. And if any terms are missing, then use a coefficient of 0 to fill the missing terms. So what does all of that mean? Let's say you were dividing x cubed minus 10 by x plus 1. The polynomial in the numerator is being divided by x plus 1. So the polynomial being divided is called the dividend. We then have our long division symbol. And outside of it, we have our divisor, which was previously our denominator. So the two parts in long division are the dividend inside the long division symbol and the divisor outside of it. And descending order means you're organizing it so that the largest exponents are furthest to the left and the exponents are going down as you move towards the right. Now this polynomial, x cubed minus 10, we don't have x to the second or x to the first, but we fill those in the dividend by adding a coefficient of 0. And we're allowed to do that because 0 times anything is 0. So 0x squared is equal to 0 plus 0x is equal to 0. So this is just to help us complete the long division process, but it does not affect the actual value of the dividend. We are not altering the value since 0x and 0x squared are both equal to 0. So let's go through the previous example, dividing 4x squared plus 13x plus 3 by x plus 3. We'll now use long division, and we'll see that the quotient will still wind up being 4x plus 1, as we saw it was when we did factoring. Step 1, organize the dividend in descending order. So the largest exponent should be furthest to the left. So we have 2, 1, and an order of 0 here. Step 2, divide the first term, 4x squared, by the term with the highest degree. The constant has a degree of 0. X has an exponent of 1. So 1 is larger than 0. So we're going to divide 4x squared by x, and that gives us 4x. We then want to multiply the divisor, x plus 3, times the answer that we got from step 2, which was 4x. When we do so, we get 4x times x, which is 4x squared, and 4x times 3 is 12x. Step 4, subtract this product from the dividend. So we get 4x squared minus 4x squared, which is 0. And we get 13x minus 12x, which gives us x. And now step 5, bring the next term in the dividend down. So the next term in the dividend is 3. So we have x plus 3. And now we're going to repeat steps 3 through 5. So we're going to divide the first term, x, by the term with the highest degree on the outside, which would be x, giving us x divided by x, which is positive 1. We'll then multiply this answer times the divisor, giving us 1 times x, which is x. 1 times 3 is 3. And then we'll subtract this product from the dividend, giving us x minus x, which is 0, and 3 minus 3, which is 0. And now that we've gone through each term in the dividend, we have our answer, 4x plus 1, with the remainder of 0 over x plus 3. 0 divided by anything is 0, so we do not need to add this to our answer. But if it were anything other than 0, then you would need to add the remainder to your answer. So the quotient of 4x squared plus 13x plus 3 divided by x plus 3 is equal to 4x plus 1. So that is how you divide a polynomial using long division. Let's have you complete a few practice questions. Question number 1. Find the quotient of negative 3x squared plus 15x minus 12 divided by x minus 4. Question number 2. Find the quotient of x cubed plus 7x squared plus 10x divided by x plus 5. And question number 3. Find the quotient of x cubed minus 10 divided by x minus 2. Pause the video, answer these questions, and then press play when you're ready to begin. Question number 1. We were finding the quotient of negative 3x squared plus 15x minus 12, our dividend, divided by x minus 4, our divisor. The first step, organize the dividend in descending order. So largest degrees to the left. So we have a degree of 2, a degree of 1, and a degree of 0. And now the second step, we will divide the first term, negative 3x squared, by the term on the outside with the highest degree. So negative 4 has a degree of 0 and x has a degree of 1. So when we divide negative 3x squared by x, that gives us negative 3x. And now we'll multiply negative 3x times the divisor. And that gives us negative 3x times x, which is negative 3x squared. And negative 3x times negative 4 gives us positive 12x. And now we want to subtract this product from the dividend. So that gives us negative 3x squared minus negative 3x squared, which becomes plus 3x squared. So they cancel each other out. And we have 15x minus 12x, which gives us 3x. And now we'll bring the next term in the dividend down. So we'll bring down negative 12, giving us 3x minus 12. And now we'll repeat steps 3 through 5. So we'll divide the first term by the term with the highest degree, which is x. So 3x divided by x gives us 3. And now we'll multiply 3 times the divisor, giving us 3 times x, which is 3x. And 3 times negative 4, which is negative 12. And we'll subtract this product from the dividend, giving us 3x minus 3x, which is 0, and negative 12 minus negative 12, which becomes plus positive 12, which would be 0. So we get negative 3x plus 3 with a remainder of 0. So the quotient is negative 3x plus 3. Question number 2. We were dividing x cubed plus 7x squared plus 10x by x plus 5. The first step, organize the dividend in descending order. 3, 2, 1. And now we'll divide the first term, x cubed, by the term with the highest degree, which would be x. X cubed divided by x gives us x squared. And now we'll multiply x squared times our divisor. So that gives us x squared times x, which is x cubed, and x squared times 5, which is plus 5x squared. And now we'll subtract this product from the dividend, giving us x cubed minus x cubed, which would be 0, and 7x squared minus 5x squared would give us 2x squared. And now we want to bring down the next term in the dividend, which would be plus 10x. And now we'll repeat steps 3 through 5. So we'll divide the first term by the term with the highest degree. So 2x squared divided by x gives us 2x. And now we'll multiply this answer, 2x times the divisor, giving us 2x times x, which is 2x squared, and 2x times 5, which is plus 10x. We'll subtract that product from the dividend, giving us 2x squared minus 2x squared, which is 0, and 10x minus 10x, which is 0. So we get a quotient of x squared plus 2x. And now let's have a look at question number 3. We were asked to divide x cubed minus 10 by x minus 2. For your dividend, whatever x terms are missing between x cubed and negative 10, we need to add those in with a coefficient of 0. So we go from x to the third, x to the second, x to the first, to no x's. Once we do that, we're ready to proceed. So we can divide the first term, x cubed, by the term with the highest degree, which would be x. X cubed divided by x would give us x squared. And now we'll multiply x squared times our divisor, giving us x squared times x, which is x cubed. X squared times negative 2 is negative 2x squared. And now we want to subtract this product from the dividend, giving us x cubed minus x cubed, which is 0. And 0x squared minus negative 2x squared is equal to 0x squared plus positive 2x squared, which would be 2x squared. And now we want to bring the next term in the dividend down, 0x, and we can repeat the process. So we'll divide the first term, 2x squared, by the term with the highest degree, which is x. 2x squared divided by x is 2x. And now we'll multiply the divisor times that answer from the previous step, 2x. 2x times x is 2x squared. And 2x times negative 2 is negative 4x. We subtract that product from the dividend, giving us 2x squared minus 2x squared, which is 0. And 0x minus negative 4x is 0x plus positive 4x, which is 4x. We'll then bring down the next term, negative 10, and repeat the process once again, giving us 4x divided by x, which is 4. And now we'll multiply 4 times the divisor, giving us 4 times x, which is 4x. And 4 times negative 2, which is negative 8. We want to subtract that product from the dividend, giving us 4x minus 4x, which is 0, and negative 10 minus negative 8, which would be negative 10 plus positive 8, which is negative 2. So with this remainder of negative 2, we divide that by the divisor x minus 2, and that would be our remainder, which we want to add to our answer. So the quotient of x cubed minus 10 divided by x minus 2 is equal to x squared plus 2x plus 4 minus 2 over x minus 2. And that wraps up this chapter on polynomials. Should you have any follow-up questions, feel free to leave them in the comments section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.